Thank you for thank you for joining us for another episode of Dispatches from the Energy Transition. Today, we're going to talk about maximizing the value of solar at Frontwave Arena, effectually do an in-depth case study on a project that Mayfield Renewables and Baker Electric worked on together for Frontwave Arena in Oceanside, California. I'm one of your co-hosts, Robert Cross. I'm the principal of Outfit. In this particular project, it's interesting because we filmed the case study and did some animation work that will be part of the episode today, trying to demystify the complexity of what was going on there and show how systems work together. As per usual, I'm joined by my co-host, Lucas Miller from Mayfield Renewables. How are you doing today, Lucas?
I'm doing well. It feels like spring here in Portland, so no complaints. And
Spring in Portland and feels like winter in San Francisco with the wind. I'm here for Climate Week, but it's been a lot of good conversations.
great. Well, for those of you who don't know me in the audience, my name's Lucas Miller. I'm a senior engineering consultant at Mayfield Renewables. I also had the privilege of going on site and checking out this project that we designed and were the engineer of record for in collaboration with Baker Electric. So really excited to dig into it today. Maybe a bit different than some of our previous episodes, really just diving into the specifics of one particular project and then trying to draw some kind of broad strokes, conclusions, and best practices from it. We're joined by two expert guests today, first of which I get to work with on a daily basis. So I'll pass it to you, Ryan, if you want to do a brief intro, yourself, your role here at Mayfield.
Sure. Thanks, Lucas, and great to be here. Thanks for having me. Yeah, my name is Ryan Mayfield, founder, SME at Mayfield Renewables. Started the company back in 2007, and we are primarily a design engineering firm, and we have a education arm. And so in the recent past, we've really doubled down, I guess you could say, on doing education and doing different sorts of trainings. Interestingly enough, we did an event down in San Diego in conjunction with Intersolar. Well, while Intersolar was happening, we did it with Clean Tech San Diego and on energy storage systems. And so kind of right in the neighborhood of where this project is at. And yeah, lots of lessons learned. And so excited to be here. And yeah, thanks for having me.
Great. Thanks, Ryan. Last but not least, we're joined by Nick Jackson, Senior Director of Commercial Solar at Baker Electric. Nick, let us know a little bit about your role at Baker, and also what's your home base? Are you in the San Diego area, somewhere in SoCal?
Yeah, thanks, Lucas. Yeah, we are just north of San Diego, not quite halfway between San Diego and LA, but in the North County area of San Diego. Baker Electric is an electrical contractor. We've been around since 1938, 86, 87 years, coming up on another anniversary here. I've been with Baker a little over 5 years, and Ryan and I, we shop at the same optometrist. We get the same glasses from the same guy. You can tell there on the screen. But we partner with Mayfield on quite a few projects. Our commercial solar group that I'm responsible for, we're a full design build EPC contractor. We do have some in-house engineering capabilities, but we also partner, like I said, with Mayfield. So happy to be here, talk about the Frontwave project, kind of a cornerstone of the North County of San Diego. Pretty cool project.
Great. And I do just want to have a couple of housekeeping reminders for folks before we really dig into it. There is a Q&A tab. We invite everyone throughout the entire webinar to put as many questions as you have into that tab. We'll be reviewing them throughout. We'll try to ask them in the moment if we can, and if not, we'll hold them to the end and ask as many as we have time for. So we're going to start like we always do, some company intros. get a bit more sense for kind of what Baker does, what services you provide, and similarly with Mayfield. You mentioned this a little bit, Nick. Baker's been around since 1938. It's pretty impressive history for a US-based electrical contractor. When did renewables become a portion of the services that you guys offer, and what does that look like today?
It's a great question, Lucas. Renewables in California obviously has been at the sort of the forefront of development. So we've been doing commercial, industrial, and utility scale renewable projects for the better part of 15 years or so now. We're coming up on 10 years as those being broken out as completely separate business units within Baker. And quite frankly, that sort of aligns with Baker's growth in the Southern California market was probably in 2013 to 2015, things really started to make a lot more sense. Excuse me, to really focus on the renewable space. So we've got some great project examples there on the screen, but specifics to what we do in renewable space, we have 4 different business units, I guess you could say. We have a utility scale PV group, which we do a lot of balance of system, multiple hundreds of megawatt projects in the middle of nowhere. We have a utility scale EPC arm where we're doing anywhere from 10 to 60 megawatt design build projects. And then my team, our C&I design build, commercial battery storage and PV. And we also have a utility scale battery storage arm as well. So I would say right now, even though we started as a full service electrical contractor, and that's what we're known for quite a bit here locally, 60 to 70% of our actual work is now through the renewable energy space.
That's a pretty significant growth, Nick. I was looking on your guys' website in the commercial aspect, and it's noting that in Southern California, businesses and organizations are paying more for electricity anywhere else in the country. So I would imagine for a C&I project that's a big driver or an incentive for a business to move forward with solar. Just out of curiosity, is anything else driving the growth other than project economics?
Yeah, we have a couple of projects a year, I would say, where what really drives the incentive for the customer is environmental and greenhouse gas offset. They're looking to do something else other than the economics. They're looking for the green stamp on their website. They're looking for environmental concerns. Or in some cases, you do have some federal mandates to calculate and also reduce your greenhouse gas emissions. Those aren't fully baked out and fully implemented yet, but we're starting to see more and more of that over the next 5 to 10 years is our expectation. But yeah, I'd say those are the top 2. Economics, how do we save money? And then the second one being, hey, we'd love to save a little bit of money, but it's not the biggest priority. What can we do to be more supportive of the environment?
Sense. And commercial is kind of broad. Is there any specific segments that you think are acting first?
That's the beauty of energy. It's sort of market agnostic. It doesn't really, or market neutral. Look at what you've got up here on the screen. You've got a cold storage. I think that's a cold storage facility on the left-hand side, or just that could be a run-of-the-mill, any commercial rooftop anywhere in the country could look like that. Then on the right-hand side, you've got an arena, very similar to the one we're talking about today in Los Angeles. So that arena, 2 completely different sets of needs, 2 completely different load profiles, but it doesn't really matter if it is cold storage, if it's office space, if it's an arena. Everybody has a pain point these days when it comes to energy. So it does actually enable us to be pretty fluid. And yes, we use that term commercial with a very, very broad sense. And you could almost apply it as, for us, commercial just means behind the meter, is a good way to kind of describe it for the technical group on the phone.
And our focus here today is on Frontwave Arena, but I gotta ask, what arena is that in the bottom right, Nick? Is this BIPV I'm seeing on the side and then a separate array on the roof, or what's the 90-second story there on this one?
So that's the Clippers Arena in Los Angeles, right near LAX, and there's actually two different. I want to minimize the window here so I can see a little bit better. It's not BIPV on the side. That's a just a decorative covering over that steel structure. But yes, you've got PV on the roof that is sort of arranged in a sort of an artistic layout. It was originally supposed to be a basketball, shaped like a basketball, but the layout wouldn't work with fire codes the way they really wanted it to. So it looks just more like a kind of spiraling flower. But if you check out the parking garage in the upper right-hand corner of that picture as well, that is a full coverage, what we like to call a monolithic or sawtooth style PV coverage. There's two parking garages with PV out there as well. But that's the Clippers Arena in LA. NBA basketball.
Yeah, the Frontwave Arena is the G League affiliate plays there too. That was kind of fun to see up close and personal. Ryan Mayfield Renewables, we've been working together for quite a while. Talk to me a little bit about how Mayfield has really honed in on C&I over the past couple of years and some of the challenges that you're seeing and how Mayfield helps navigate those challenges.
Sure. So yeah, we've definitely, so as when I started the company, we were, I've always done C&I, always done commercial projects. And as we were growing up as a company, growing with the industry, we were doing smaller projects, we were doing some residential. And then a handful of years ago, we really decided that the C&I space is where we best fit and where we thought we were bringing the most value. So we really just put all of our efforts into that. So we are, like Nick said, behind the meter projects is really it doesn't, what the building is, what the type of location it is. Not that it's doesn't matter at all, but we're looking at all of them. And so all of our projects are behind the meter. They're, not getting into utility scale, not doing residential. So that mid-market arena is where we're at. And one of the things that I think we've found as far as, challenges within this space, well, there's multiple challenges within the space, but I feel like the complexity on some of the projects can get, there can be quite a bit of complexity, especially as soon as you throw in energy storage as a emerging technology, pairing that with solar. There's definitely design considerations and engineering considerations that get complex really quick. And so I think that's part of where we really like to be anyway, as the projects are more interesting and definitely work that side of our brain, make us think, come up with good solutions for different solar plus storage projects.
Yeah, I like how you mentioned really focusing on the complexity there, Ryan, and in particular, just attachment rates for commercial PV systems tend to be going up. Like we're seeing more and more need for storage, microgrids. Nick, is that something that you guys are seeing as well on the Baker side? Are storage attachment rates in California or elsewhere going up?
I'd love to say in theory, yes. In theory, it makes a lot more sense with net billing tariff and the way that our customers are compensated for their generation. In theory, yeah, batteries do make a lot more sense. I would say Ryan mentioned obstacles and hurdles, but the moving target that seems to come up when it comes to like, okay, cool, batteries make great sense in your analysis and they make a ton of sense on paper. But then when you actually go to build it and you actually go to move through the permitting process and work with the different folks who want to, hey, I want it this way, then I want it this way. And it does become the more complex, it's longer to get them done. So I would say the industry in California has a little bit of time to see before we really hit peak concentration of attachment, like when we really start to see on every project, they make a lot of sense. And because there's a lot of cost, that just hidden cost in these projects, that once you start throwing batteries in there, you get a price from a distributor or a manufacturer, and they're like, oh, hey, this is all it is. You just put this in. And then, Ryan's team gets involved, my team gets involved, and we look at it and we're like, yeah, that's we need to have some conversations. So we're getting there. The industry is getting there. Education, the things that Ryan and his team are doing to educate the AHJs, educate the customers, educate the other engineering firms, is free consulting that he does for his competition. It helps move the industry forward. But yeah, we're not quite where I think where it's going to be in 2, 3, 4 years.
Thanks for that, Nick. I think Nick's kind of teeing up the education side of the business, and you've been at that for quite a while, focusing on codes and standards, and Mayfield's really invested in education. You have your summit later this year. What do you think can accelerate the market adoption of storage? If you had to pick, I mean, obviously that's a broad question, but if you had to focus on one thing, what would it be and why?
Wow, that is a great question. It's a pretty big one. For me, the education and training is at the heart of when I started the company, that was one of the very first contracts I got, was doing education, and definitely something that I have really fallen in love with and really have a passion for. So I think educating around energy storage systems in general is important and would really help move the needle. So we were at that event I mentioned with Clean Tech San Diego. Nick was there as well, some folks from Baker, and I think just getting everybody on the same page, understanding battery systems as a whole, understanding what the real risks are, what the real benefits are, and how we can match these with our electrical systems is important. So for me, it's, I think, a lot around education and making sure that people understand energy storage systems, and being, acknowledging the risks that are there. There's never a zero risk proposition when it comes to energy, when our power generation or anything like that. So I think doing that would be my magic wand if I had it to be able to do.
Be careful, I can draw a caricature of you with the magic wand next. Thanks for that. And go to the next slide, Lucas.
Yeah, so let's get into this project. So we've looked at a few examples, kind of talked broad strokes, but the rest of the episode, we're really going to focus in on Frontwave in particular, which you see in the upper left. Upper right is inside. We're just talking about the LA Clippers NBA team hosts their home G League team games there. There's also an indoor soccer team, plays their home games, hosts concerts, events throughout the year. I think it seats about 7,500. I'll kick it off with you, Nick, just kind of from the onset, if you were involved, kind of when did this project get kicked off? I know this is a part of a bigger movement in Oceanside, in this particular region within Oceanside, to really focus on sustainability and community engagement. So how did this project come to be, and what were some of the motivations going into it?
It's a great way to kick this off, Lucas. And you can actually see, I love these pictures because they give you a little bit of context of what else is going on. And you alluded to it. You can see the new housing developments surrounding this area. This is a big development opportunity for the city of Oceanside. This is hundreds and hundreds of acres of new green space that is being redeveloped into arenas, housing, as well as providing commercial space for life science. And actually over to the right-hand side of that picture, which you can't see, but if you were to Google Maps this, I think there's 20 to 30 soccer fields, outdoor soccer fields. This is a very, very large, highly active area that not too far away from the ocean. But so this was part of a project that I think the original land use conditional land use permits were filed and applied for back in 2018, 2019 timeframe as part of the development of the entire region. And so we got involved in, I think it was 2021, was with the development owner as they were sort of planning out the feasibility of the site. And I'd say the big driving factor wasn't necessarily the economics or even the environmental. So like those two big things didn't apply quite yet on this project because it didn't exist. They had some sample information from other similar facilities, and that's how they kind of said, okay, this is what we think the size needs to be. This is what we think we want out of a battery storage project. But it was sort of hey, I guess we're going to see after it gets installed and kind of go from there, and we hope we're good. This was definitely more of a sustainability play as part of the CEQA process for this county of San Diego and the city of Oceanside to sort of move the city forward in terms of achieving their sustainability. And I don't want to say net zero, that's not the right term to use, but you can definitely hear that kind of tossed around in this industry a little bit, misappropriated to true net zero. But that was sort of a driving factor, was if we're going to spend this much money, we're going to bring this much development into this area, how can we make sure that there isn't an adverse environmental impact as a result of the traffic, the people, the congestion, and the energy usage.
Thanks for that overview, Nick. Very, very detailed. And you were talking about the drivers for the project. I mean, obviously now today we're operating under net metering 3.0. One of the big issues there is reducing the value of solar exports. Recent episodes of dispatches have focused on peak demand and time of use from a variety of perspectives. How does Baker wrap your arms around explaining energy management and time of use and this economic complexity that's inherent with solar plus storage and control?
How do we explain it? It depends on and I'm sure a lot of folks appreciate this, it depends on who you're talking to and what their familiarity is with solar. A lot of times one of the first questions you ask is, do you have solar and batteries at your house? Do you read your bill for your own property? And that can really set some good baseline for, okay, who am I talking to? What do they know? How technical and detailed do I want to get, or how high level do I want to stay, just to kind of help them understand one of these things, or understand these things. One of the things that I like to do, depending on the customer, is I'll actually sometimes I'll show them how they use their power with a graphical analysis software, and it, because pictures more often than not, and especially a lot of us on this call, we're engineers, or we used to be. So we appreciate pictures versus words. So showing them, hey, this is how you currently use power. This is where solar is going to come into play. And you start to layer these things on top of each other and toggle some things on and off. And they start to go, oh, okay, I totally see how this makes sense. And oh, I see. So I start paying 4 times more for my power at 4 o'clock in the afternoon than I do at 3:30, which is certainly a factor for a property like Frontwave, who, I mean, right now it's 12:30 here local time. There's nobody there. It's not using any power, but it's the best time of day for solar. So that thing is pumping right now, but nobody's using it. Come 4 o'clock this afternoon, people start rolling in for an indoor soccer game or a concert or something like that. The air conditioning turns on, the stadium indoor lights are running, the TV screens, and all of a sudden your energy usage goes up. But we all know that's when solar stops being effective. So properties like this, as well as that other arena we showed, batteries make a lot of sense. It really does help them justify the expense of doing these projects.
Yeah, and we'll definitely dig in a bit more into net metering 3.0, demand charges, some of the finances in an upcoming slide. I do want to revisit something you mentioned there, Nick, and maybe pull you in here, Ryan, on the battery sizing. This was a new build, like you mentioned, Nick. Project was initiated 2018, 2019. it's getting built today, we don't have loads to estimate battery size from. We're really using our best guess. Maybe it's a synthetic load profile. I know at Mayfield, we do more and more feasibility studies for microgrid solar plus storage systems. So what are some best practices for that type of scenario, Ryan, where maybe it is a new build or something in the early planning stages where we don't have concrete load data to go off of?
Yeah, one of the things, so yeah, exactly. In the feasibility studies that we're doing a lot of, we are doing new buildings, and Nick mentioned this actually too. So they had some other similar buildings that sound like that they were looking at and being able to use some comparative analysis, I guess you would say, in that situation. And so that's what we are very often doing. We're using synthetic load profiles to estimate what the load is. With a building like this, exactly what Nick, what you just described was there the day we were filming. It was, we showed up at 10 in the morning and there were all of 3 people in the entire building. And, by the time we're leaving, there's a state championship basketball game going on or something like that. And so the profile is changing over the day. And so if you can have a synthetic load profile, that's great. Another thing that we have done is, working with on new builds, working with electrical engineers. They have an idea of what is happening. They just may not know the exact timing. And so trying to work with the building engineers, working with the building owners, the occupants, understanding how that building actually gets used is an important aspect of it. And that would be typically our approach on how to tackle that problem on a new building.
I'll kind of follow that up, and I'll leave this to Nick or Ryan, either one of you or both of you. So given the project complexity, standalone PV, and contrast with storage, and you add on further complexity with control and microgrids, what, from your individual perspectives as a project developer, and then Ryan on the consulting engineering side, what value do feasibility studies have in theoretically they're mitigating risk and trying to align opportunity, but how do they become more mainstream, or just afford your perspective from your respective seats?
It sort of depends on how you define a feasibility study. I think that's part of how deep do you want to go into something, and how much do you want to bake into that upfront review? Because to do something as, let's say this building was existing, right? And it did have a load profile. It did have some data from the last 12 to 24 months or something. And the feasibility study is as simple as, hey, let's get some green button data. Let's overlay some PV on it. Let's do some trial and error. Let's analyze, let's optimize, let's get through a comparison of tariffs, of potential rate switch tariffs. So you could almost call that a feasibility type of study to a certain extent, but it would be more of a developmental feasibility study. I think what Mayfield has really found an opportunity for is something that's a little bit more deep and complex, and has a lot more considerations. And Ryan, I'll let you kind of take that one.
Yeah, no, I appreciate that. And it definitely, it can vary in a situation where, I don't want to belittle it or anything like this, but in a situation where you're doing grid services. So you are doing either energy arbitrage or you're doing demand charge management. That's a different use case. That's a different animal even than if you are trying to do what I would call a true microgrid, where power goes out and you are supplying power for that facility. And so the difference, both of those deserve a feasibility study. Both of those definitely should have one. But to Nick's point, they're at a different level. And there's, very big financial implications on both of them. But in a situation where you're just doing, again, I'm not trying to belittle it by saying just doing grid services, but when that is the core focus or the core reason for the batteries, then that's a different way of looking at it. And the financial side of it is dominating. On the other side, if you're doing a microgrid, I would say the finances, of course, matter, but very often when you're doing a microgrid, you're doing it because of some extreme event, and the value of having power and energy in a natural disaster way is, way beyond what the financial aspect is. So the technical feasibility of it becomes a much bigger issue, I would say. So I guess I could probably say a lot about feasibility studies, but in all situations, understanding what the system can do and is it going to serve the needs for what your customer is expecting is really the big thing, whether that be grid services or working in a natural disaster.
And we got a question from.
There's no one size fits all approach. This kind of challenging aspect of this.
Right, and we got a question here from Drew Gillette in the audience. Given that electrification is ongoing, isn't every project kind of like a new building in that you also have to consider future loads and not just past loads? And I think that's a great point, Drew. Certainly something that in our process we ask about upfront is, are you going to install an EV charger or a fleet of EV chargers on your facility in the next few years? Like what does your plan, your personal plan for your facility look like over the next couple of years? Do we need to overbuild the system now? Do we need to build preparing for future additions that can handle that increased load? I'd open it up, Nick or Ryan, is that how you guys understand it? Is there more to it than kind of just having that conversation with folks up front in the process?
It's incredibly important, because the last thing you want to do when let's use Frontwave for example. You start this project in 2021, it goes online 2.5, 3 years later, and they've completely changed how they use power, and it comes up on a regular basis. So being proactive with them, asking the right questions. EV chargers is a great example, Lucas, especially in California. Are you going to add them? How many are you going to add? And there's great ways to layer those predicted loads as a simulation on top of the existing green button data. But yeah, you have to ask the questions 100%. That's the most important part of it.
Absolutely. And the what I would say and this gets into the feasibility process, it's very iterative in the sense that we talk with the clients, we work with the contractors, here's how the building's going to get used, present some results, and very often it's like, oh, but what if we did this? What if we wanted to do that? And being able to do analysis on that, adding EV chargers, or in the situation, again, I know Frontwave is not this situation here, but in a microgrid application, what do the loads look like now that it's being used as a shelter for folks because of a hurricane or something like that? So the use case day to day may look quite different than what it would be when you're wanting to use the batteries in that type of situation. So understanding that's part of that whole process as well.
Okay, we are getting a few more audience questions on kind of equipment specs, how this battery is being used on site. I do want to ask one more question to you guys first. This was a PPA project, so power purchase agreement with another developer. Nick, can you explain to the folks in the audience who may not know what a power purchase agreement is and how a company like Baker and/or Mayfield would get involved in that type of project?
Absolutely. So we've talked a lot about asking questions and really honing in on what the customer needs. What are their goals? Do they want the capabilities that Ryan talked about to be able to provide shelter during a natural disaster? Is the economic drivers of a project the primary goal here that they want to achieve? We ask a lot of questions at the beginning of all of our development opportunities, and in this case, like I mentioned, I can't believe it was just I think one slide ago. I've talked a lot, but the economic drivers wasn't a huge driver for this particular customer. They were looking for more of the sustainability, the environmental. So we presented them with the opportunity to lock in their energy costs for a 20 to 25 year period, which is that's what a power purchase agreement does. Is somebody else owns and operates the system, and then in this case, Frontwave just pays for the energy that it generates, just like it. So our local utility here in San Diego is San Diego Gas and Electric. So Frontwave gets two bills. They get one from SDG&E for whatever they pull in from the grid, and then they get a bill from the PPA provider, which is based on whatever the PV and the battery generates.
And I've seen quite a few solar PPAs, but very few storage PPAs. So if you're familiar, Nick,
Yeah.
can you explain kind of the nuances of how that works? Like, do grid services, investments get applied to that PPA payment, or is there more to it?
So sometimes yes, maybe never. You can answer it all like all four different ways there. Because yes, so typically PV is the one thing that you've always counted on. It's more of a passive device. It doesn't make decisions. It doesn't have inputs and outputs. There's not really a controller that says turn on and off, right? It's on, it generates power, sun goes down, you're good, right? The battery has a brain. The energy system has a brain. It's making decisions, and you can tune and optimize that for whatever sort of grid services that you want to utilize. It could be a self-generation incentive program that you want to maximize, or again, I'll go back to Ryan's point. Hey, maybe you really want to just hold on to as much of that power as you possibly can because it's fire season, right? And you want to be able to provide a shelter for the local community. So they have somewhere to go if there's a public safety power shutoff, right? So there has been a struggle for the financing market to find a way to value to put an economic or financial value to what a battery can offer, right? So in a lot of cases, what they're doing right now is valuing the grid services because there is a true economic payback, whether it's the DSGS program or the SGIP. So they're primarily focusing on those two mechanisms as being the factor in the PPA rate, the per kilowatt hour rate. And then everything else is sort of icing on the top of the cake that may or may not happen because they're not going to promise or expect an economic return on something that they don't know is going to happen. So in this case, we don't have islanding capabilities on this one, do we, Ryan? I think this one is strictly a grid services. And I think a lot of that could be driven because of the PPA rate structure. If this was more of hey, strictly for Frontwave and they wanted these capabilities, and it's always something we can go back in the future and update the controls and hardware, but it'd probably be valued a little bit differently from the customers and operators' perspective.
Yeah, and you're absolutely right, Nick, and that maybe brings us to a great transition point to look at the system itself, kind of how this battery is being used. Like you mentioned, this is not an islanded system, not what we would technically call a microgrid. What's really happening here is your PV, like you mentioned, it's 12:30 right now, local time. There's really no one in the facility, right? But that's also peak PV production time. So that power is getting sent into the batteries, and then those batteries are discharged later in the day, which for an arena like this is conveniently when it's busiest. It's also in San Diego gas and electric territory where rates go up exorbitantly from 4 to 9 p.m. And so we actually want to use that power later in the day where it's most valuable. And so what we have here is just a really rough approximation of the facility loads throughout a typical day, 8 a.m. to midnight, with that 4 p.m. to 9 p.m. window marked with the $sign, also coinciding with perhaps the busiest time for the arena on an average day and the highest local demand. This is a fairly common use case, I think, for commercial, but Ryan, I'd love to hear from you. Like, is this most of what we're seeing at Mayfield? Are there other common solar plus storage commercial use cases beyond this that we're seeing?
Yeah, so thanks for saying all that, and because I threw out grid services without really defining it earlier. And so grid services being exactly what you just talked about. So using the solar, you have a battery system, and using the solar to charge the batteries, and then discharging the batteries when the facility is using that power in order to offset what the utility has to provide at that point. So really kind of a self-consumption, if you will, of that power. And so just minimizing what the utility has to provide. So that is a big thing that we're seeing, especially California in the projects that we're involved in. And the other part of that whole situation, or part of that grid services, I mentioned demand response. And so for facilities that have demand charges, which large facilities will always have demand charges, but if you have motor loads that are kicking on, HVAC units that are kicking on, drawing a high amount of power, instantaneous power, by having a battery system there that can inject the power, keeping the utility at a flat rate so you don't go above a certain amount of kilowatt draw, then that will really help the finances as well. And so those two things combined, I would say, are a big part of what we're seeing in terms of the grid services battery systems. For us at Mayfield, we also see a lot of the microgrid. We have positioned ourselves specifically for that. So we are seeing outside of California, especially, or even inside California, because of the public safety power shutdowns, the PSPS, that we are seeing where, the utilities, to avoid starting fires of their own, as we've seen, down power lines sparking fires. And so the utilities response has been to turn off the power to stop transmission. But then that really puts local folks at a disadvantage. You be without power, could be for days. And so having these abilities to have true island systems, microgrids. So that's the flip side of, these, where you are actually creating your own grid, you're able to power up your loads. And so I would say those are the two that we're seeing. I think we might be seeing a disproportionate number of microgrid systems just because that's where we've positioned ourselves and what the work that we're really looking at. But we definitely see both of those.
Nick, from a project developer perspective, Baker Electric has a storied history. You're approaching 100 years as a company, situated in California, which has always been kind of on the front end of the energy movement. I'm just kind of curious. The utility rates are on the rise. There's a lot of complexity with peak demand, time of use. How aware are your prospective customers about the opportunity with solar plus storage, and how much do you have to educate them? Like, where are we at as an industry talking to the asset owners themselves?
Somewhere between really fatigued and curious. Because so obviously California, we've talked about it. Solar's not new, right? Battery storage is not new. Every other house in most neighborhoods has a power wall or equivalent. They understand it at the residential level. So we struggle sometimes because I'm going to use this word, but it's not true. They're overeducated to a certain extent, and sometimes they're a little bit sour on the concept of it because they may have had a poor experience at their home with their home residential installer. So I would say, a lot of times our education when it comes to solar and storage is not necessarily about the technology or what it can do. It's actually about building trust in that you're there to help them and you're there to consult. And it's okay. It's okay if you don't do this project. We're totally fine with that. We think it's a good idea. Whether you do it with Baker or you do it with somebody else, you should do this. So we still think that there's quite a few untapped opportunities in the market, but folks are just, I think there's some fatigue, to be completely transparent. I think microgrid, to Ryan's point of where they've positioned themselves, I think that's a great spot to be in right now because people don't know a lot about microgrids, or they think they have an idea of what it is, and in reality they don't. So the education really helps them sort of come around and be like, oh, I see value in that. Like, how do I get one? So it's
And so you talk about trust and partners. I think that's a key aspect for the industry to move forward. the proof is kind of in the pudding of these projects and adhering to timelines and the economics and performance is critical. Before I push it back to Ryan, what gets you optimistic about where we're at? I mean, there's always challenges in this industry. I've been in it myself almost 20 years, but is there something that has you optimistic?
Has me optimistic. Solar's getting cheaper. It's getting more cost effective. So for some customers that have held off because, hey, yeah, we get the idea, we like it, but it's just we're just not there yet. We're not in the right space. These projects are getting more economical to compete from a material perspective. Quite frankly, I hate to say this. This is sort of, again, they keep raising the rates, right? It's the energy's not getting cheaper, and yeah, it feels a little. I don't want to use. I mean, again, if I was a politician, I'd be terrible because I'm gonna use it. It feels predatory at times. Again, there's a little snapshot of Nick saying we were predatory on CNN tonight, but rates keep going up, and they keep making solar make sense, even with net billing tariff. So, but I also trust that there's some really good entities and outfits out there that really are doing what they can in Sacramento to kind of restructure some of the misconceptions around things like the cost shift, and really show that solar isn't really costing people more money. But legislation has always been something that's pushed and pulled at the renewable energy space for the last 20 years and will continue to do so. And we'll keep riding those waves. The solar coaster, I believe it's called.
Thanks for that, Nick. Brian, I'm just going to throw something to you before Lucas gets in the codes and standards. When I was interviewing you on site for the case study and we were talking about batteries, one of your comments that really stood out to me is storage is complex, right? And project developers don't necessarily are aware of the complexities. How does Mayfield work as a partner? How do you reduce complexity or educate in this aspect of the space?
Well, we take an approach of, I would say, trying to educate on multiple levels. And so for us, a lot of the education is around codes and standards for the contractors and the engineers. Nick said that earlier, of educating our competition, which in a sense, yes, in a sense, it's educating the industry more than anything. And so that's a big part of it, of trying to reduce the complexities of getting folks understanding the whys of what we're having to do with codes and standards, and then how to implement it. And then other parts of the education that we're trying to reduce complexity is by getting information out there to AHJs specifically. The AHJs are tasked with, the authorities having jurisdictions, they're tasked with having to go out and do plan reviews, or plan reviews are submitted to them. They have to review them. They have to know all these things. That they're being tasked with being experts in something that at Mayfield we have a whole team spending that's all of our time, and they're having to review every single building and things like that. So trying to make that information a little bit more accessible for them as well is important to kind of help demystify it and help the whole industry really being able to understand what's required, what's not, in order to get safe and effective systems installed.
Yeah, and I think what's another interesting aspect here is just how variable, especially utility rate structures, can be from state to state. So I'm up in Oregon. We have abundant hydro resource. Electricity is 10, 12 cents kilowatt hour. Time of use rates really don't exist here yet, or not to an economic degree. But you go one state south to California, and like you mentioned, Nick, rates keep going up and up and up, 10% plus each year. On top of that, there's the net metering 3.0 change in the last year or two, which cut the value of solar exports by about 75%. So when I see that, I mean, some markets are inherently going to be more attractive maybe to this type of project than others. And from your perspective, Nick, in the California market, it sounds like you maybe haven't seen a huge bump in storage attachment rates since net metering 3.0, despite the value of that solar export going down. You'd think that that may increase the value then of self-consumption, perhaps just using more of your local energy and avoiding paying the utility at all. I've seen some stats online, the payback period now for solar plus storage is faster than for solar alone. But is that the boots on the ground kind of understanding that you have of this new net metering landscape? Is there more to it that folks maybe aren't aware of?
You nailed it, Lucas. I mean, it's in all the math. I mean, you see, right, this is a great thing to have up on the screen as we talk about this. If you were exporting any of the solar in the middle of the day at 3-4 o'clock, you're getting a significantly less value for that right now. So if you can hold on to it, you can store it, you really reduce those peak demand or the other charges you would face from 4 to 9 p.m. So net billing tariff has really put a lot of that emphasis on that sort of analysis. So the teams, the developers, like our counterparts in this industry, are constantly doing it. And I saw this one question here of in the chat about matching the battery storage, dispatch time, or energy duration with the 4 to 9 p.m. Like, do you want to go for the full 5 hours? How much of the peak demand or how much of the demand do you cut down? Do you cut all of it? Like, what's the secret sauce? And the answer is there isn't any. Right? Every project is different. Every project's got fixed limitations and boundaries based off of either how much solar can you put out there, how much battery can you really fit somewhere. So you've got physical limitations as well as engineering limitations, economic limitations of what the customer may or may not want to spend. And it's a constant development of how you're trying to size these projects to maximize your self-consumption, but then also de-risk yourself, or hedge your bets against future rising rates. So it's net billing tariff has changed where in an M2 world, you could pretty much size a project for 100 to 120% offset of annual energy usage. A customer would have a really good little bump in the middle of the day where they're sending their power out onto the grid for not quite retail rates, but they're getting a good return on that investment. And then you could see a full solar project maybe pay for themselves in 3 to 4 years. Now that same number, that same site, because they're not getting those exports, that if you would put the same exact size system on there, maybe that goes to 7, 8, 9, 10 years on that payback time frame. So you make the system smaller, right? You don't need all these exports. Let's make it smaller. Okay, let's change the inverter profile. Let's change the inverter setup. So we're gonna flatten that curve a little bit instead of make it so peaky. How do we get more energy at the beginning of the day and the end of the day? And then hold on, let me take a look at this. What kind of battery can I fit out there? It's the analysis, you could call it analysis paralysis, you do at the beginning of these projects just to figure out what am I going to recommend to this customer, can be very, very deep. Whereas in December of 2022, it was, what do you use? Okay, 100, 120%, go. You'll be in great shape.
Great, thanks, Nick. And I know we've got a few minutes left here and one more pretty sizable topic to get us to. So I'm going to keep us moving. Starting with you here, Ryan. This last one we want to touch on is just fire safety considerations, how we're siting these batteries, where they're located, what's around them. So if you could give us, Ryan, the 90-second kind of elevator pitch, like where's the industry at with regard to large-scale fire testing and interpretation on these storage systems?
Yeah, I was going to say, I like that you started this with less than 6 minutes to go. So we have hours we could talk on this topic. But the 90-second pitch, I'll see if I can do it. So where are we at as an industry? Where are we at with codes and standards? It's evolving, to say the least. Right now we have a UL standard, so 9540 that is a listing, that's a standard that the manufacturers, the energy storage system manufacturers will go through, and it's a safety standard. So they have to go through certain tests, make sure that their batteries, pass all of these safety tests. On top of that, there's the 9540A test data, which I'm sure a lot of the folks in the audience are familiar with. That is probably the moving target. I know that UL has working groups that are working on updating 9540A, and we have CSA, which is another nationally recognized testing lab that has their own large-scale fire test standard that has been released. So where the industry's at was where we are getting better about it. We're learning and we're understanding how these systems act. We're learning how to test these systems so that they are safer. And so if there ever is a fire event, whether that is with the storage system itself or maybe just the facility itself, the firefighters have a much better understanding of what to expect and how to protect the building, how to protect the surrounding area, what are their firefighting activities going to be. So yeah, we are definitely learning a lot as we go. And I saw that there were some, at least one question about, how is this addressed in this specific case for Frontwave. And that image that's on the top there is a great one to visualize, where we have some number of battery cabinets, and because of the space limitations Nick was talking about, we there's physically just so much space we could install these in. And so using 9540A test data to show that when there is thermal runaway within each of those cabinets, how does it affect the cabinet next to it? And that's the data that we get from the manufacturers. We present that to the AHJ in order for them to feel comfortable with, yeah, you can put those closer together, and there are provisions for that in code. So that's kind of the short answer on how to put those units closer together. Of course, there's a lot more to it, interpreting the data and all that, but that is kind of the short answer on that one.
I'm going to throw another curveball or screwball out there for Ryan and Nick, and I'm just kind of curious about this. So, electricity demand growth is considerable year over year. It's kind of unprecedented in recent times. It's being driven by electrification and a number of factors, AI, and data centers, another facet. So when I look at it being in the industry, there's a fair amount of impediments, right, to meet this growth. There just seems to be a lot of conflict here between trying to meet the forecast and then wrapping our arms around technologies and so on and so forth. Like, how do we get this done? I know it's like a giant question, but like, how do we make things move faster? And is it even possible?
I mean, getting all of the folks at the table is an important part. Getting the utilities involved, and I think that's been one of the biggest impediments for trying to move. We have some very, what I would say, progressive utilities that are being very proactive, others that maybe are very much less so. And yeah, to the kind of point you made, Robert, I've talked with folks in Santa Rosa, which is in Northern California, where putting in a building and the utility's telling them, that's great, you're putting in a building, we don't have power for you for 3 years. Like, it's in the middle of town, and we can't supply you with power, sorry. And so that's a huge impediment to growth and being able to do what we want to do. So utilizing all the resources we have, being able to get more storage involved, more solar involved, I think is one of the, in my mind, is one of the easy answers. But I know nothing's actually easy in that situation.
I guess I'll just make a comment and throw it to Lucas or Nick. But I think ratepayers being disgusted is probably a growing issue as well.
I don't know what the answer is. I gotta be honest with you, Robert, because it is like there's one hand's not talking to the other. I think you've got goals. I think you got grander goals that sit at the macro level, but then the micro, like, hey, here's how we actually do it. I think that's where the challenges face, because you got folks that sit let's say the top tower, top floor of the tower, and then you have the folks that that actually have to figure out how it gets done safely and how it gets done with the public's best interest in mind, and as well as the customers' rooftops, and it's there's a lot to try to get to by 2030 and 2040, and to hit those grander goals.
Yeah, I think we're recognizing that, and time kind of marches on. I know it's not an easy topic or anything easy to answer. Lucas, why don't you wrap us up here, because I see we're closing on the hour.
Yeah, we are right at 1 o'clock. As always, close out with some key takeaways for folks, some net metering impacts on financials, fire code requirement impacts on system design. And something that we didn't get to really talk much about today is just the role of energy management software and controls that enable some of these grid support features that we talked about, including demand response and energy arbitrage. Want to thank Nick and Ryan, our two guests today. We've got some contact information on screen if anyone wants to get in touch with either of them. Also wanted to thank Solar Builder, who is a sponsored partner of our webinar series. Any final thoughts, Robert?
Yeah, I really appreciate Nick and Ryan taking the time today, walking through the Frontwave Arena project and getting to film it as well for both companies. We'll be back next month and probably delve into something with microgrids. Thanks, everyone.
Thanks.
Thanks all.
Thank you.